The first step towards achieving your dreams is having the right coach. Get the best education with Dr. Monica Jain and make your CBSE 10th, 11th and 12th dreams come true. Download the app now.
So in my earlier video, I have talked about the general introduction of the isomerism. What is isomerism? But now in this present video, I will cover this topic in detail according to the 11th class CBSE syllabus. So let me start then. So briefly, in a simple way, what is isomerism? We can say when two or more compounds which have the same molecular formula but they differ in their chemical and physical properties, then they are called isomers, and this phenomena is called isomerism. So this isomerism is also broadly of two types. First is called the structural isomerism and second is the stereoisomerism. So structural isomerism means what? When the two molecules with the same molecular formula but they differ in their structures from each other, then they are called the structural isomerism. Then they are called the structural isomers, and this phenomena is called structural isomerism. And the second type, stereoisomerism, means when the molecules or isomers which have the same structural formula but they differ from each other in the arrangement of atoms and group in the space, then they are called the stereoisomers, and this phenomena is called stereoisomerism. So this stereoisomerism is not in the 11th class CBSE syllabus, so I will not cover this stereoisomerism, but only I would like to say here that this stereoisomerism is further of two types, geometrical isomerism and optical isomerism. So here I will cover in detail about the structural isomerism. So we know this structural isomerism is also of various types. First is the chain isomerism, second position isomerism, third is functional group isomerism, fourth is metamerism, fifth is tautomerism, sixth is ring chain isomerism. So one by one I will cover all of them in detail. So then structural isomerism. So I will be discussing all the types of structural isomerism. So as I have said earlier, when the compounds which have the same molecular formula but they differ in the arrangement of atoms within the molecule, then they are called the structural isomers, and the phenomena is called structural isomerism. So this is, I hope it is clear. So then the first type of structural isomerism is the chain isomerism. So what does it mean? So means that the compounds having the same molecular formula but they differ in the arrangement of carbon chain in molecule. So only difference is there between them with respect to the arrangement of the carbon chain. So this carbon chain can be the straight chain also, or it can be a branch chain. So then they are called the chain isomers. So we can understand this with the help of this example. Suppose this is C5H12 molecular formula is there. So if we have to write the chain isomers for this. So this is, we can say this is pentane. 5 carbon atom are there and this is pentane C5H12. So if we write the isomers in this case, so first possibility is there to write in the straight chain, simplest way. So this is the straight chain form of the pentane. So, and this is called the N-pentane. This is the normal pentane straight chain form. So we can write it in the form of the branch chain also. Suppose we take only 4 carbon atoms in the parent chain, like this, and 1 methyl group as a branch chain. So here we can see parent chain is having the 4 carbon atoms and 1 methyl group is as a substituent, and this is the another way to write, and the name for this will be 2-methyl butane. 2-methyl butane. And the another way, another way is there to write this. We can take 3 carbon atom chain as a parent chain and 2 methyl group as a substituents, like this. So in this way also, like we can write this pentane, and the name for this will be 2,2-dimethyl propane. 2,2-dimethyl propane. So these are the 4 various ways to write C5H12 pentane molecule. So in all these 3 forms, molecular formula is same. It is same C5H12, only they differ in the arrangement of the carbon chain. So this is the straight chain, and both these are the branch chain. So this is the chain isomerism. So moving on to the next. So next is the position isomerism. So what is this? Position isomerism means compounds having the same structure, means the molecular formula will always be same in the case of isomerism. But such compounds which have the same structure of carbon chain, means the carbon chain is same in all the molecules, but they differ only in the position of the multiple bond. So in case of multiple bond, means if double bond and triple bond are present, so they will differ only on the basis of the position of the double bond or the triple bond. Or if the functional group is present, so they will differ only on the basis of the position of the functional group. So such type of isomers are called the position isomers, and this phenomena is called the position isomerism. So let us see this with the help of the examples. So suppose I write this but1ene. This is but1ene. So how will we write CH3, CH2, CH and double bond CH2. So this is but1ene. Position of this double bond is at the number 1 carbon atom. So we can write it in the another way also, like this: CH3, CH double bond CH. This is CH3. So here we can see the name for this will be but2ene. So we can see both of them differ only because of the position of the double bond. Here the position of double bond is at the first number carbon atom, and here the position is at the second number carbon atom. So that is why it is called the position isomerism. So we can see one another example also. Suppose we take this molecule propan-1-ol. This is propan 1 all. So this can also be written as keeping this functional group on the second number carbon atom. This can be written like this also. So name for this will be propan 2 all. So we can see here that both these isomers differ only because of the position of the OH group here at number 1 carbon atom and here at the second number carbon atom. So that is why both these are the position isomers, and this phenomena is called as the position isomerism. So next is the functional isomerism. Functional isomerism means when compounds having the same molecular formula but they differ, but they have different functional groups. So when they have the different functional groups, then they are called the functional isomerism, and the phenomena is called the functional isomerism. So we can understand with the examples. So in organic compounds, many classes of organic compounds show the functional isomerism. So we can understand it with this example of C2H6O, the compound having the molecular formula of C2H6O. It can be written like this in the form of alcohol CH3 CH2OH. So here we can see 2 carbon atoms and 5 plus 1 6 and 1 O. So this is the alcohol, or we can write it in the name of this is ethanol. This is a alcohol. So this molecular formula can also be written like this, CH3OCH3, and this is CH3OCH3. So here we can see again the same two carbon atoms and 6 hydrogen atoms and 1 O. So this is what? This is the ether. This is ether. So here we can see the molecular formula of the organic compound is C2H6, and we can write it in the form of alcohol also. Here we have written CH3CH2OH. This is the alcohol and having this functional group of OH. And it can also be written like this, CH3OCH3, and this is a ether and the functional group is O. So both these are having the same molecular formula, but how they differ from each other? Only on the basis of the functional group. So that is why they are called the functional isomers. So we can understand with another example also. So here I have written C2H4O2. This is the molecular formula of a compound. So we can write it in the form of carboxylic acid like this, CH3COOH. Okay, so this is in the form of carboxylic acid, and second way we can write it like this also. Second way of writing it is so in this way also we can write, and this is the name for this compound is methyl methanoate. This is methyl group, methyl methanoate. So this is a ester. This is a ester because this is having COOR group. So this belongs to the ester family. So here we can see the organic compound with this molecular formula can be written as the acetic acid also, which is the carboxylic, which is having the COH functional group. It is having this carboxylic acid COH functional group, and it can also be written as this methyl methanoate, and this is having this COOR functional group. Now means that this belongs to the family of ester. This is a ester and this is a carboxylic acid. So hope this is clear. So next example also we can see, like we can take this example of aldehyde and ketone. So if a compound which is having this molecular formula C3H6O. So first it can be written simply in the form of ketone. We can write it like this, CH3COCH3. So this is propanone. This is propanone, 3 carbon atom it is having. So this is the ketone, and we can write it in the form of aldehyde also. So if we write it like this, CH3CH2, C double bond OH, this. So this is the aldehyde, CH3CH2CHO, and this is called propanol. So both of them have the same molecular formula, but how they differ in terms of the functional group only. So this is having the ketonic functional group and this is having the aldehydic functional group. So another example we can see, like if suppose there is a compound having this molecular formula C7H8O. So simply we can write it in the form of phenol. We can write it like this. So here we can see 7 carbon atoms are there and how many hydrogen? 4, 5, 6, 7, 8. 8 hydrogen atom and 1 oxygen. So this is the form of like a phenol form. So in this way we can write, and another way of writing this is like this, OCH3. So this is in the form of ether. So we can see both of them have the same molecular formula, but how they differ from each other only in terms of the functional group. Only in terms of the functional group. Both are having the different functional groups. So name for this compound is orthocresol, and for this it is anisole. So this was all about the functional isomerism. So now next is the metamerism. So this metamerism is also very important type of isomerism, and many times it is asked in the exam also, in terms in form of the short note, or like some molecular formula is written, is given to you, and you have been asked to write the metamers for that organic compound. So what are the metamers or metamerism? So such compounds which have the same molecular formula but different number of carbon atoms, or alkyl group on either side of the functional group, like in this ether and then thioether or amine or ketonic functional group, are called metamers, and this phenomena is called metamerism. So in a simpler way we can understand, in such functional group like this is the ether, where it is having the alkyl group on both the sides. Like here, this is left side R, right side R dash. Or suppose thioether, like thioether in such compounds where both the sides it is having the different or the same alkyl groups. In the case of amines where both the side alkyl groups are there, or in the case of ketones where both the side alkyl groups are there. So in such type of functional group we can see this metamerism. Yeah? And so we can understand it with the example. So let us take first this example. Like we suppose we take this CH3. First I am taking the example of the ether. Suppose this is this ether I have written, and the name for this ether in a common way, general way we can say this is the diethyl ether. Diethyl ether, because both the sides it is having the same groups, same alkyl groups are there on both the sides, and this is the ethyl group. So name will be diethyl ether, the general name. And it can also be written like this. You can say that this is the symmetrical ether, because both sides of the functional group it is having the same alkyl group. We can write it like this also, CH3O, CH2, CH2, CH3. So here we can see, okay, this is the methyl group and this is the propyl group. So what will be the name for this? The name we can write this common name like methyl and propyl ether. Why? Because this is the methyl group on one side and the another side it is having the N-propyl group. So name will be methyl N-propyl ether. So this is the unsymmetrical ether. So how they differ, both of them, how they differ from each other? Molecular formula is same in both the case, only they differ in the number of carbon atoms on the either side of the functional group. So in this case, this is the symmetrical ether and this is the unsymmetrical ether. So both are called the metamers. Okay, so we can say diethyl ether is a metamer of methyl and propyl ether. So this was in the case of the ether. We can take one more example, like in the case of ketone we can see. So ketone, suppose like we take this symmetrical ketone. Same way, CH3, CH2, C double bond O, CH2, CH3. So here also we can see this is the functional group and both the side same number of carbon atoms are there. So this is a symmetrical ketone and the name for this will be diethyl ketone. So we can write it like this also, CH3, C double bond O, CH2, CH2, CH3. So here we can see this is the methyl group and here this is the propyl group. So again in this case what will be the name? Methyl N-propyl, because this is the straight chain. So N-propyl ketone. So this will be the name. And one more way we can write this, we can write it like this also, C double bond O, and here CH3 and this CH3. So this we can see here this is the Yes. So here we can see the number of carbon atom in this and in this case. In this and in this case, both are same on either side of the functional group. Are same. So it can be written in this way also, but this will not be the metamer of this. This will not be considered as the metamer, because in both these cases, the number of the carbon atom on either side of the functional group are the same. So in this case also only two metamers will be there, this one and this one. So this will not be considered. This is the isopropyl group. So this will not be considered as a metamer of this compound. So here I would like to add one more point. These metamers are also known as the position isomers. अभी मैंने एग्जाम्पल्स डिस्कस करे हैं आपके साथ फॉर मेटामेरिज्म. सो अगेन आई हैव रिटन हेयर सो दैट इट कैन बिकम वेरी क्लियर टू यू. So I have given the names A, B, C. So A, if we see, it is diethyl ketone, and B is methyl and propyl ketone. So we can say both of them, A and B, are the metamers. And then next is the C, which is methyl isopropyl ketone. So if we see here, A and C are also called as the metamers. But if we see in the case of B and C are not the metamers, because in both cases on the either side of the carbonyl group, same number of carbon atom chain is there. So that is why B and C are not the metamers. And one more important point which I have told earlier also, कि these like A and B are also called the positional isomers, because they differ in the aspect of the position of the functional group, which is the ketonic functional group. In case of A, the position of functional group is 3. So that is why for IUPAC name it will be called pentane 3-on. And in case of B, IUPAC name will be pentane 2-on, because the position of the ketonic group is 3. So that is why both A and B are also called as the positional isomers. Now I will discuss with the fifth type of isomerism, which is called the tautomerism. So this is a special type of functional isomerism in which isomers exist in dynamic equilibrium with each other. Means there is a equilibrium is established between the two isomers in the case of tautomerism. And this tautomerism arises because of the migration of one hydrogen atom from one atom to the other atom within the same molecule. So this takes place because of the migration of a hydrogen atom from one place to the another place within the same molecule. And these type of isomers are also known as the tautomers, and this phenomena is called the tautomerism. So this keto-enol tautomerism is very well known, is very popular. So why it is called keto-enol tautomerism? Because in this case, one isomer which is in the keto form gets converted into the enol form. Now, so basically there is a equilibrium is established between both these isomers, in which one is in the keto form and the another in the enol form. So what are these keto and what are the enol form? So keto means the isomer or the tautomer which is containing the ketonic group. Carbonyl group means that this ketonic group it is having. Because of this ketonic group, it is called the keto form. And enol means en plus all. En plus all. En means double bond, all means hydroxyl group. So such isomer or tautomer which contains a double bond and a hydroxyl group, this OH group, so then it is called the enol form of tautomer. So then I will now explain it with the help of the example. So here I have taken this propanone, or you can say acetone, you can say this. So this is the propanone and this is in the form of the ketone. This is having this ketonic functional group, CO functional group. So this gets converted into this compound which I have written here. So here we can see CH2 double bond COH CH3. So the name for this is prop 3 carbon atom parent chain prop 1 en 2 all. So as I have discussed just now, this is the enol form. Why this is the enol form? Because this carbon, 2 number carbon is having this double bond also en and this one OH hydroxyl group also. That is why this is the enolic form. So this keto form is getting converted to the enolic form and there is a dynamic equilibrium which is established between both of them, keto and the enolic form. So here we should understand one thing, that this keto form, in this equilibrium, this keto form is having the higher percentage of 99.7% and this enolic form is in negligible amount only. So so we can see here why this keto form is 99.7%. It is because of the greater stability of this ketonic form, because of this C double bond O, which is a stronger bond in comparison to this enolic form, where this C double bond C is a weaker bond. So that is why, because of the greater stability of the keto form, this keto form is found in the higher percentage of 99.7% in this equilibrium. So this is how, like this tautomerism we can understand. So in a simple way, if we want to understand, so if I write this keto form like this, so here we can see, here I have written this keto form like this. This is C double bond O CH3, C double bond O CH3. This carbon I have written like this, and this is having 3 hydrogen atoms which I have written like this. So what happens? The electronic displacement takes place. Electron displacement takes place like this. So this double bond, first this double bond between the carbon and oxygen will break, and this oxygen will develop the negative charge. And then what happens? This carbon hydrogen bond will break like this. will break like this. And this hydrogen will come out, and this hydrogen will get attached to this oxygen atom. So let me write like this. So this hydrogen is coming here with oxygen, so it will become OH. So both these hydrogen are same on this carbon atom, because this CH bond is breaking here, and here this C double bond is becoming single. So both these carbon atom to have the tetravalency. So because we know carbon is tetravalent, so here double bond will be formed. So in this way we can see that the hydrogen, the migration of hydrogen atom, this hydrogen atom migration is taking place from this carbon to this oxygen, atom. So this migration of hydrogen atom from one atom to the another atom is taking place within the same molecule, and thereby the dynamic equilibrium is established between the two forms of the isomers, and this is called the tautomerism. So here also this is the keto form, this is the keto form, this is C double bond O, and this is the enol form. So I hope now it is clear to everyone, because in the simple way, this is the very simple way to understand. So again I will repeat. So what is happening? So this ketonic form, only this propanone only I have written like this. This carbon I have written in this, having the 3 hydrogen atom in an expanded form. So what is happening here? So this double bond, this carbon oxygen double bond is breaking, and electron is shifting like this towards the oxygen atom, and this carbon hydrogen bond will break, and this hydrogen will migrate from here to this oxygen, and thereby here on this carbon it will have one OH group, hydroxyl group, and because this bond and this bond is breaking, so here there will be the formation of double bond between both these carbon atoms. So that is why this enol, one double bond, en plus ol, this double bond and one OH hydroxyl group is there, and enol is formed, and the dynamic equilibrium is established between both these keto and the enol form. So here in this tautomerism, I want to again discuss some key points. So first is very important to understand, this is a equilibrium between the keto and the enol form, not resonance. So keto-enol tautomerism cannot occur if a proton on alpha carbon atom cannot be removed. So next, second point is, equilibrium generally favors the keto tautomer, as just now I have explained. And the next important point is, keto-enol tautomerism is catalyzed by acid or base. Type of isomerism is called the ring chain isomerism. So what is this? So when the compounds have the same molecular formula but possess open chain and cyclic structures, then they are called ring chain isomers. So means कि they differ only कि either they have the open chain structure or cyclic structure. So let us understand with the example. So if we take this C3H6, so it can be written like this, CH3, CH double bond CH2. So what is this? This is propene. This is propene, or we can write it like this also. And this is cyclopropane. So we can see here both of them have the same molecular formula C3H6, here also C3H6. So this is the open chain form, this is the open chain, and this is the cyclic structure. So they are called the ring chain isomerism. One more example we can see, C4H8. So in a simple way, open chain structure we can write it like this: CH3, CH2, CH double bond CH2. So this is, what is this? Here we can see C4 and H8. So this is butene, this is butene, your butene 1 also you can say, butene 1. So another way of writing it is like this. Simply we can write like this, and this is cyclobutane. This is cyclobutane, and one more way is there to write it. It can be written like this. This is the cyclopropane ring having the CH3 group here. In this way also it can be written, and this is the methyl cyclopropane. This is methyl cyclopropane. So this one is the open chain, and both these are the cyclic structures. Both these are the cyclic structures. So this is the ring chain isomerism. So this all I have covered in detail about the isomerism, topic of isomerism according to the 11th class CBSE. Okay, so thank you so much.